right, welcome back to part 2 of the quotient rule list. For this one, they're giving us the function, they're giving us the derivative. We just have to show that that's true using the quotient rule. So our derivative should be the derivative of the top. So derivative of x squared is x, derivative of 3x is 3, derivative of 2 is 0, times the bottom, minus the top, times the derivative of the bottom. Derivative of the bottom would be 2x and 0. That's all going to be x squared minus 1 squared. So let's see, this is 2x squared times, 2x times x squared is 2x cubed. 2x times negative 1 is negative 2x. 3 times x squared is 3x squared. 3 times negative 1 is negative 3. I've got negative 2x times x squared is negative 2x cubed. Negative 2x times 3x is negative 6x squared. Negative 2x times 2 is negative 4x. All over x squared minus 1 squared. All right, I got 2x cubed and negative 2x cubed. They'll cancel out. I got 3x squared minus 6x squared would be negative 3x squared. Negative 2x minus 4x is negative 6x. And then minus 3. All over x squared minus 1 squared. I see these guys all have 3 in common, so I'm going to go ahead and factor out that 3. Actually, I'm going to go ahead and factor out a negative 3 because they all have negative 3 in common. So pulling out a negative 3, I've got x squared. Negative 6 divided by negative 3 is plus 2x. Negative 3 divided by negative 3 is 1. All over x squared minus 1 squared. Well, is that what they have? Nope. Looks like we're going to have to get rid of this chunk here because I see a negative 3, but I don't see anything after it. So let's go ahead and factor that guy. So negative 3. This guy would be x plus 1 squared, right? Let me write it this way. X plus 1 times x plus 1, right? It's 1x plus 1x, we're giving by 2x. 1 times 1 is 1. This guy here, remember, is x minus 1 times x plus 1. But it's squared, right? So we have 2 of each of those. All right, what cancels out here? I've got an x plus 1 and an x plus 1, and I've got 2 x plus 1s down here. These guys all cancel out, and we're left with negative 3 over x minus 1 squared, which is what we have up here. So we did a good job showing that. All right, similar to the product rule, they're a very, very valuable lesson that we must learn when we are introduced to the quotient rule. In the box below, first factor and simplify the function from above, then differentiate using the quotient rule. Okay, so now they want us to factor first and then differentiate. So let's see if we can't make this a little simpler. What are two numbers that multiply to 2 add up to 3? That'd be x plus 2, x plus 1. Factoring out x squared minus 1 would be x minus 1, x plus 1. What cancels out here? X plus 1. And so we've got x plus 2 over x minus 1. Using the quotient rule then, we've got derivative of the top, which is big 1, times the bottom, minus the top times the derivative of the bottom is just 1 over x minus 1 squared. All right, so this is x minus 1 minus x minus 2 over x minus 1 squared. I'm not sure what happened here. All right, x's cancel out, and I've got negative 3 over x minus 1 squared. So which one was easier, this big carry one, or the one below where we did the factoring first? So hopefully you're saying factoring first was a lot easier, Miss Harris. I should probably try to factor before I start solving or using the quotient rule on any of my problems. All right, that was the whole point of this page, was just to show you that if you factor first before you use the quotient rule, it makes the quotient rule a lot easier in the end. All right, come back and we'll start doing some more problems in video number 3.